Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistants, and today we're looking at X-ray diffraction by crystals. X-rays of wavelength of 0.173 nanometers strike a crystal. The rays are reflected at an angle of 18.9 degrees. Assuming that our principal quantum number is equal to 1, calculate the spacing between the planes of crystal atoms that is responsible for the angle of reflection. This may seem like a very complicated request, but I promise you it is much easier than you think. All we have to do is look at what we are given. We're given a wavelength of 0.173 nanometers. We're given an angle of 18.9 degrees. We're given a principal quantum number of 1. And with those three things, we can calculate what the distance is, very simply, because there is an equation for it. Its distance is going to equal n lambda over 2 times the sine of theta. N is our principal quantum number, lambda is our wavelength, and theta is our angle. So this is a relatively easy problem. The only thing we're going to have to do is we're asked to do this, and we want to do it in terms of picometers, simply because it is easier to relate back to what we're in terms of atom size and the spacing between atoms. If we do it in nanometers, we're going to have a very small number. So for the sake of convenience, let's just go ahead and change our wavelength from nanometers to picometers. So 0.173 nanometers. And you can either directly relate nanometers to picometers. I find it a lot more organized if I just relate everything back to meters and then back to whatever it is that I'm trying to get to. This assures that I know exactly where my numbers are and there's not going to be any calculating mistakes. Because if you remember that nanometers are 10 to the 9th and that picometers are 10 to the 12th, you won't have to correlate them to one another. You could just do a 10 to the 3rd power, but again, I find it a lot simpler if you just simply relate them back to meters, because then you avoid any chance of making a mistake. So nanometers cancel out, meters cancel out, you're left with picometers. I probably should write the unit there. So all that makes it into is 173 picometers. So that's relatively simple. So coming back to our distance equation, let's plug in the numbers. We've got 1. We've got, for lambda, 173 picometers. 2 times the sine of 18.9 degrees. And when you plug that into a calculator, or do it by hand if you're a masochist, you end up getting 267 picometers. And that's our final answer for the spacing between the planes of crystal atoms responsible for the angle of reflection.